So guys, we were discussing about the different voltage levels for logic gate ICs. So in short, you just need to remember that when you see VIH, it means voltage input high level. So what voltage level will be considered as high at the input? And high means 1, binary 1. VIL means input low. So what voltage will be considered as low, or in other words binary 0? That voltage is called as VIL. Similarly, the same notation is used for the output. The only difference is between I and O. So VOH, O for output. So output high voltage, so that voltage will be taken as 1, and VOL, output low, OL for output low. So this is the voltage, low voltage at the output, which will be considered as logic 0. So the same way we have uh, notation for the current as well, as you can see here, IIH. So I hope you can easily guess what does it mean. It's also written here, high level input current. Okay, so IIL is low level input current. The previous one was high level input current. This is low level input current. So all of this is general information. Okay, if you remember it, it's easy. It's not difficult. So you just need to see whenever you read any data sheet, you might find these kind of symbols or notations. So you should understand that what this actually means. ICC is high level supply current, and ICC 0, ICC 1 and ICC 0 is low level supply current. So all of these terms are given with a definition which you can refer to. Okay, now we will discuss some more characteristic of logic IC. The first one is propagation delay. The propagation delay is the time required for the output of a digital circuit to change state after a change at one or more of its input. What does that mean? In simple words, you can say that when a logic gate receives any input, in how much time it will be able to give you the output. That is called propagation delay. Okay, so because the logic gates, they are behaving at input logics, depending on the input logic, they are giving you one output logic. So it's only the time delay between input and output, how fast a logic gate is able to give you the output. That depends your processor speed, or your mathematical function performance speed, speed of your calculator, your computers, your mobile phones, will depend on this propagation delay. The propagation delay should be as much less as possible. It is more desirable to have very small propagation delay. Usually it is in the range of nanoseconds. Nano means 10 to the power minus 9. It's very low. So, okay, fan in. There are two terms actually, fan in and fan out. It is actually the number of input signals that can be connected to a gate without causing it to operate outside its intended operation range. Simple words, you can say fan in means how many number of inputs a gate can handle correctly. So basic logic gates, they have two inputs, but there are logic gates which can have more than two inputs. So that is called fan in. And fan out, it is the maximum number of inputs that can be driven by a logic gates. Okay, so it is based on that, it has to provide some output. output load factor. So this is actually output load factor and this is input load factor. Fan in is input load factor, fan out is output load factor. So it gives you the understanding of the logic gate range, how many inputs it can easily handle at the input and how many inputs it can easily handle for producing an output. Noise. Noise is the difference between VOH and VIH. Now, what are these terms? VOH, I hope you can understand. VOH is the output high level. VIH is the input high level. So difference between those is the noise, undesirable thing. Power dissipation, or in other words, consumption of energy in a logic gate. So every electronic circuit, every electronic component, electrical component, they need some power or they consume some electrical energy for for its function. So that is called power dissipation. So we want such electronic circuit which use very little energy, that is more desirable. So you can understand that you don't want your mobile phone battery to go down very quickly. So what you have to do, you need to use such uh, components, such electronic circuits which are using very less power. And also you want its speed to be very high. You want all the functions to be performed very quickly. So what you have to think about, you have to think about this propagation delay. So propagation delay must be very low so that the overall processing speed is high. Okay, again there are some different types of logic families mentioned here, which some of them we already discussed. So these are the different types of logic families. Mostly we use TTL. The TTL series is mostly used in our labs as well. So, but depending on the design and the requirements, one can use any type of series. Okay, this is just a comparison table between different types of ICs. Okay, now it's basically giving you various characteristics which are not really desirable in your course. I mean, this is not part of your course, but this is just the general knowledge information. You can have a look on it in your free time if you want to. But I will go on to a more simpler slide, which is giving you some important details about TTL IC. So TTL IC, which is mostly used, which is most common, its input signal range. You need to understand that 0 to 0.8 volt is low. Low means binary 0. Okay, so voltage is between this range 0 to 0.8 volt. It means the logic gate will understand it as 0. Similarly, if the voltage is 2 volts and up, then it will be considered as high. High means binary 1. What we are talking about now, we are talking about input signals. Okay, so because the logic gate, it will only understand the voltage levels. So it will see if the voltage is between 0 to 0.8 volt, it will understand that 0 is coming, binary 0 is coming. And 2 volts and above, it will understand that this is binary 1 coming on the input. Similarly, we have output signal levels, which you can see here. 0 to 4 volts is low. So when the logic gate is giving you an output of 0 to 4 volts, you should understand that it is giving you a low level, means binary 0. And if it is giving you 2.4 volts and up, then you should understand that you are getting binary 1. Okay, so two common IC types, which are TTL and CMOS, their comparison is given. But again, this is just only for information, which you can read through in your free time. Okay, now there are some general questions. The most common TTL series ICs are, this is the series number. If you remember, uh, we used some regulator IC series. We studied it in our last term about regulator ICs, which are used to give you a regulated voltage, and they used to have certain number, 78 series and 79 series. So same way, each electronic component has a specific part number. So the TTL ICs, they are mostly in the range of 7400. So this is their series number, right? So here are different multiple choice questions, and which you can refer to. Luckily, the correct answers are also mentioned in red color, but you can verify these answers from the previous slides, that either these are really correct or not. So the presentation will be available in your contents area. You can check the presentation, and you can do these multiple choice questions by yourself to test your knowledge and test the correctness of these questions as well. So I will stop the recording and I will open the forum for question answer session.